This is PreCalculus 12, Chapter 6.7. We're going to be looking at applications of sinusoidal functions. And for real-life applications, radians is not the unit for trig functions. Typically, time is the unit. So you need to get comfortable with converting the period to radians. Recall that b is equal to 2 pi radians per period. And often in these problems, b will involve pi. And that's because the period won't have pi in it, so the pi's won't cancel out. For some problems, sinusoidal functions will model the problem exactly. For other problems, it will produce a close approximation. Example, determine a function to model the graph below. And here on the vertical axis, we have displacement. Here we have time. It doesn't specify the units, but we could say this is seconds. We could say this is centimeters. Here we look and we have the center line. D equals 1. And we look at the amplitude. Be careful of the scale here. 1 is 2 grid units. So if we go up 1 grid unit, that's half a centimeter. So A equals max minus center line. That's 1.5 minus 1, and that's a half. Let's look at the period. It starts here, ends here. Period equals 3 minus 2, that's 1. So B equals 2 pi over 1, that's 2 pi. C is our phase shift. We're not told whether we're modeling with sine or cosine, but let's pick the most convenient one. This is the center line. It extends all the way over here. And because this y-intercept is on the center line and goes up, we should model this with sine. So C is equal to 0 for sine. If we happen to choose cosine, the max is over here, so we would need a phase shift of 1 over 4. So it's not quite as convenient to model this with cosine. And now we've got all our constants. So 1/2 sine, 2 pi t, phase shift is 0, plus 1. So let's use the common Ferris-Wheel example. If we were asked to find out the diameter of this Ferris wheel, it would be a very tiny Ferris wheel. We would measure from here to here for the diameter. So we would say diameter is 1.5 minus 0.5 equals 1 centimeter. If we were asked for the radius equals the amplitude, and that's 0.5 centimeters. If we were asked for the hub of the Ferris wheel, it would be on the center line. So the hub would be at 1 centimeter. So it's important to know what all these constants mean and how to answer questions. So for word problems, pick out the key information, determine A, B, C, D. Sometimes the info will be direct, other times it will be indirect. So the radius of a merry-go-round is 6 meters. This implies A equals 6 meters. The diameter of the Music Express is 10 meters. So A equals 10 meters divided by 2. So it's 5 meters. The bottom of the Ferris wheel is 3 meters and the top is 18 meters. So we can actually determine two things from this. So amplitude is 18 minus 3 divided by 2. So this is 15 over 2 meters. And we can determine the center line. D equals 18 plus 3 divided by 2. This is 21 over 2 meters. It's best to leave this as a fraction to imply that it's precise. Otherwise, if you answer with a decimal, we're assuming that that figure is rounded. Often in real-life problems, we're given a table of data. We're going to model this data using a trig function. So you need to determine certain information off this chart, and you need to see which numbers are going to be the most accurate for you. We look through the list, we scan, we see this is a max. We see this is a min. And you have to decide whether you want to start at the y-axis or somewhere off the y-axis. So I like to start on the y-axis. So January represents t equals 0. And if we have that, that means December is t equals 11. So let's calculate the center line and the amplitude. D equals 20.83 plus 4.34 divided by 2. This is the center line. And this works out to 12.585. It's okay to use decimals because we already started off with decimals. And the amplitude, A, amplitude, max minus min over 2. Just to remind you of what we're using, 20.83 minus 4.34 divided by 2. This gives us 8.245. And just a reminder, this formula is max plus min over 2. It really doesn't matter if you do min plus max over 2 because addition is commutative. We can change the order. However, subtraction is not commutative. You cannot change the order of the subtract. Okay, here's something you need to infer. We don't know what the cycle is. We don't see it repeat anywhere. We see a 6.12, we see 6.05, that's close. However, this is going up and this is going down. So it means that this one goes up and connects to there. So 12 months completes the cycle. Okay, and that makes sense because this is hours of daylight by day of the year. So B equals 2 pi over 12, and that equals pi over 6. And as I mentioned before, most of these real-life problems, we will have pi in our B value. So we have a choice. We can use sine or cosine. Each will have a different offset. So if we look at the center line going up, it would be 12.6 going up, or 12.59 going up. This is pretty close to 12.59 going up. So for this one, t equals 2. So our function is y equals 8.245 sine pi over 6 t minus 2 plus the center line 12.585. Let's go back up to the graph. Cosine starts at the maximum, so this is t equals 5. This is 0, 1, 2, 3, 4, 5. So we can choose either way. Y equals 8.245 cosine. Notice that these values don't change. It's just the offset. Pi over 6, t minus 5, plus 12.585. So using tables can be tricky. We're not absolutely right, we're not absolutely wrong, but it's a matter of making better choices. Sometimes you can't find a value close to the center line, so use cosine and max. The table above is okay for sine or cosine because the table of values is not far off from the center line. Some of these tables, they don't model quite nicely, so if you have a value like 11.5, then that's too far away from the center line. I would use cosine to model it, and that's what this comment is about. So if you can't find a value that's close, use cosine. And that completes this lesson and chapter.